Evaluating a mathematical expression in a string. This returns the following error. I know that eval can work around this, but isn't there a better and, more importantly, safer method to evaluate a mathematical expression that is being stored in a string?
Parsing can be used to parse mathematical expressions. In particular, forfn.py shows how to parse basic arithmetic expressions. Below, I've rewrapped forf into a numeric parser class for easier reuse. You can use it like this.
Eval is evil. Note, even if you use set_built-ins_ to none, it still might be possible to break out using introspection. Evaluate arithmetic expression using AST. You can easily limit allowed range for each operation or any intermediate result, for example, to limit input arguments for a b. Or to limit magnitude of intermediate results. Example.
Some safer alternatives to eval and simpy.simplify.evalf. Astival, numexpr. Simpy Simplify is also unsafe according to the following warning from the documentation. Warning: note that this function uses a val, and thus shouldn't be used on unsanitized input.
The reason eval and exec are so dangerous is that the default compile function will generate bytecode for any valid Python expression, and the default eval or exec will execute any valid Python bytecode. All the answers to date have focused on restricting the bytecode that can be generated, by sanitizing input, or building your own domain-specific language using the AST. Instead, you can easily create a simple eval function that is incapable of doing anything nefarious and can easily have runtime checks on memory or time used. Of course, if it is simple math, then there is a shortcut. The way this works is simple. Any constant mathematic expression is safely evaluated during compilation and stored as a constant. The code object returned by compile consists of d, which is the bytecode for load_const, followed by the number of the constant to load, usually the last one in the list, followed by s, which is the bytecode for return_value. If this shortcut doesn't work, it means that the user input isn't a constant expression, contains a variable or function call or similar. This also opens the door to some more sophisticated input formats. For example, this requires actually evaluating the bytecode, which is still quite simple. Python bytecode is a stack-oriented language, so everything is a simple matter of toes equals stack.pop, optoes, stack.puttoes or similar. The key is to only implement the opcodes that are safe, loading/storing values, math operations, returning values, and not unsafe ones, attribute lookup. If you want the user to be able to call functions, the whole reason not to use the shortcut above, simple make your implementation of call_function only allow functions in a safe list. Obviously, the real version of this would be a bit longer. There are 119 opcodes, 24 of which are math related. Adding store_fast and a couple others would allow for input like x equals 5, return x plus x or similar, trivially easily. It can even be used to execute user-created functions, so long as the user-created functions are themselves executed via vmeval, don't make them callable. Or they could get used as a callback somewhere. Handling loops require support for the Godot bytecodes, which means changing from a for iterator to while and maintaining a pointer to the current instruction, but isn't too hard. For resistance to DOS, the main loop should check how much time has passed since the start of the calculation, and certain operators should deny input over some reasonable limit, binary_power being the most obvious. While this approach is somewhat longer than a simple grammar parser for simple expressions, see above about just grabbing the compiled constant, it extends easily to more complicated input, and doesn't require dealing with grammar. Compile take anything arbitrarily complicated and reduces it to a sequence of simple instructions.